Okay, hi everyone. I think I can start class now. Today we will move on to the section 10, 10.7. That is chi-square distribution for association. Chi-square for distribution test for association. The last time we studied about the chi-square, but it's used for goodness of it. But today we will move on to another problems. Okay. As you can see on the table, we turn our attention to assessing whether two traits or characteristics in the populations are associated in some way. Okay, as you can see on the table 1, this is the table for university admissions number to a program that is observed frequency. As you can see, the numbers 35 represent for the student, the male student who are admitted to the university. That is the number 35. And the number 45 here, that means that represent for the number of students who are male and denied when they apply to university. And female 20 here, that means there are 20 female students who are admitted to university. And they have the table like this. And the question here is, whether the gender, male or female, is related to admission status. Okay, that means when they accept the student to university, they are care about the genders or not. That means that question here. That means that the gender discrimination exists when we look at the table. Does the gender discrimination exist? Okay. So today we will show this question. When we have the table like this, we have information like this. So how do we know the gender discrimination exists when we consider a table like this? Okay. That's the purpose of today. Okay. And the method of chi-square test can do this for association. We will find the connection. We will find the association between two characteristics in the population. Here we have two characteristics. That means we have the male and we have female student. The student are female, the student are male. Okay, two characteristics. And before moving on to the method, we have to consider what are the known and what are the known and alternative hypotheses. In a chi-square test for association, we have two hypotheses as follows. As you can see on the screen, the known hypothesis are the two variables in the population are independent. That means that is not related. They are not related. And the alternative hypothesis, that means that the two variables in the population are not independent. That means they dependent and they are related together. And that is the known and alternative hypothesis. Okay. As we can see in the table here, the question here is, does the gender discrimination exist? That means that we have two variables here. The variable here is the student are female and the student are male. And we have two hypotheses here. Is the no hypothesis. That means that there is no association between the gender and admission status. Okay, that means the gender and the admission status are not related. And alternative hypothesis, that means there is some association between the gender and admission status. That means the gender and admission status have some relation. That means the difference between them. And the no hypothesis that is independent and the alternative hypothesis is dependent. Okay, that is the no and alternative hypothesis when you deal with the problem about the association in chi-square test. Okay. And how do we make the decision when we have two hypotheses like this? How do we make the decision? Here I will introduce to you the method of chi-square test for association. When we consider this, we have to care about the condition to apply this method. When we apply this method, first thing, the sample data. The sample data are randomly selected, and the second one, we have to know the observed frequency. That means we have the number of students here. That is the frequency, right? We can apply this method. If we don't have this information, we cannot apply this method. And the expected frequency for each category at least 5. Okay, I will talk to you how to calculate the expected frequency in the section C. Okay, how to calculate it. And okay. And in the section C, they will provide you some formula to apply this method. We have to know what is the expected count, what is the chi-square test statistic, and what is the degree of freedom. And when we have this information, we can make the decision about the no and alternative hypothesis. Okay, so we will look at the expected count. Expected count we will calculate by this formula. Expected count will be calculated by the row total times the column total over table total. Okay, what does it mean? I will consider for you the table here. Look at the table here. I will show you how to calculate the expected count. Okay. This kind of information plays crucial role when we do the chi-square test for association. Okay, and as you can see on the table, we have the information about the male and admit. Okay, this is 35, right? 35 here. That means that there are 35 male students who are admitted to university, and we. How to calculate expected count? Okay, we have the expected count of male and admit calculated by this. Okay, we look at this one. We look at the total admit. Okay, total male here. Look at the total male here, because we care about male, right? So we look at the total of male. The total of male here is 80 people, right? 80 people. That is the total of male. And after that, we look at the total of admit. Total of admit. So we look at here. This is the total of admit here is 55. And we over the totals of people. Okay. The total of people here is 140. Okay, is it clear how to calculate this? And using calculator, so you will enlarge this. We calculate this is approximately or equal to 31.43. That's either the expected count for male student and who are listed to the university. Okay, and similarly, we can calculate the expected value. Expected count for male and denied, something like this. How to calculate this? How to calculate the expected count of male and denied, and they are denied to university. How to calculate this? So using similar formula to calculate this. Could you tell me how to calculate this? Okay, number 2, please.
You will take the male times the
Male, right? So you look at the total of male. 80, okay, exactly. 80. Times
45.
D9, 85, right? D9 is 85, right? D9 here, okay, look at this table, D9 here. The total of D9 here is 85, right?
Yeah.
Okay, 85. And over to the total of people who are investigated here is 140, right? So it's approximately, okay, approximately 40, okay, 48.57. Thank you. So this is the way to calculate the expected count. Okay. Sometimes we don't write down. Okay, so you can calculate the expected count of female and deny and admit. Okay, same similarly, and you count the expected value. Okay, expected count of female and deny similarly. And after that, you can put to the table. You need to write down here, but this is the way to do this. Okay, and I will easy for you to put in the table. I will put everything in the table. So I put in the table. So we have here is admit, right? This is the deny. This is the male student, the female student. So this is the expected count of male and admit. Right. This is the expected count of female and admit. Right. And this is the expected count of male and deny, and this is the expected count of female and deny. Okay, is it clear, guys? That is the way to calculate. I just list all the expected count to this for you to understand how to do this. And the expected count for male to admit. So you will count. Your calculation, like you will count how many male students. Okay, here we have 80, right? We have 80, and we have how many admit. You will look at this one, 55, right? And over 140. Similarly, you do for this one. And after that, you will find the expected count for each kind of characteristic. Okay, the characteristic here is male and admit, and the characteristic here is female and admit, something like this. So you can calculate it. Okay, I provided the result here in the table 2. Okay. Or the result here in the table 2. Any questions so far about how to calculate the expected count? Okay. Hope you can do it. That is the first step when you do the chi-square test statistic. Okay. Okay. And now, when we have the expected count, when we can calculate the test statistic for chi-square test, this means we can briefly we can calculate the chi-square test statistic. We write this. And we move on to how to calculate the chi-square test. Let's say sometimes we write like this chi-square. Okay, sometimes we write just like chi-square test statistic. Chi-square test statistic. How to do this? Okay, the chi-square test statistic will be calculated by this formula. Okay, the chi-statistic is that's meaning the measure measure the distance between the observation count and the expected count. That is the meaning of the chi-square test. They just want to know what the distance between them. And now we have the table here. We have the table here. As you can see on the table here, the 35, that means 35 here, the number 35 here. That means that the number of students who are males and who are admitted to the university, that means the observed frequency. The observed frequency. The observed frequency, that means it's half in the table. It half in the table. It's different from the expected count we considered before. That's okay. The observed. Okay, this is observed. Observed. Okay, I write the O here. The observed of male and admit. Here is 35, right? We don't need to calculate because it's half on the table. The O of male and admit is 35, and the O of male and deny here. The O of male and deny here is 45. That's the what we call observed count. Observed count. This kind of is called observed count. Okay, when we have the observed count, when we have the expected count, we can calculate the chi-square test statistic. How to do this? We will use this formula. Sometimes this kind of formula is difficult for you if we have a lot of data in the table. We have a lot of rows, we have a lot of columns. So sometimes we will use this. It's very hard when we have a lot of information on the table. So it will make you confused. Okay? And now I will make a table for you to apply this method. Okay? And I will write down step by step how to calculate the chi-square test by using this table. So I will list the observed. I will list the observed count here, and we will list the expected count here. Okay, expected count here. The observed count here, you can look at the table 1. We have the observed count here. For example, male and admit is 35, right? Male and admit is 35. That means male and admit, right? And what about expected count? About expected count, we use the formula like I mentioned you before. This is the table 2. That is expected count. How to calculate it? And we have the male here is 31.43. That is expected count. The observed count here is the reality. That is the number of students in reality. And the expected count is the number of students in theoretical aspect. Okay, and you can see that two numbers here are similar, are close together, but it's different. But they are different. Okay, that is observed count, expected count. Similarly, we look at another one. We have the male and deny here. Male and deny here is 45. It's the male and deny. That's the observed count. And what about its expected count? The expected count is 48.57, right? Okay, similarly, we have the 20s, and the expected count will be 23.57, and 40s is the 36.43. That's the observed count and expected count. We list when we calculate. We need to list all the observed count and expected count first. Okay, and after that we will calculate the next column. We will calculate the observed minus the expected count. Observed minus expected count. So we will count with 35 minus to 31.43, and we will get the result here is 3.57. Right? Similarly, we do for these numbers. we do for these numbers. So we get the result like this. That's either observe, expect, observe, minus, expect. Any questions so far? Okay, I just do the list by step by step to find the chi-square test. Okay, when we have the observe minus expected count, we can calculate the observe minus expected count square. Okay, we just square, that means we just square this number. Okay, that means the 3.57 times to 3.57, and we will get the result like this. Okay, we will get the result like this. And we have the result here is 12.49, so it's the same. 9. Okay. And the final one, we will calculate the observe minus expect square over expected count. That means we will using this value over to this value. Okay, let's see, we calculate like this over to this value, and the value will be like this, 0.4. Similarly, we do like this over to this number. Okay, similarly, you can do for this one. And after you finish the table like this, you will make the sum of these. And the value here is exactly the chi-square test statistic you need to find. When you finish the table, you make the sum of the final row, final column. So you will find the sum here. The sum here is the chi-square test statistic we need to find here. You don't need to follow me. You don't need to follow the way I do here. You can apply this formula if you want. Okay. The table here is just the way I think that is convenient for you when you calculate the test statistic. Otherwise, if you don't like it, if you don't like to write a table, you don't need to do this. You can apply directly the formula here. Okay. But here I think it's inconvenient for some students. Any questions so far? Okay, that's the way to find chi-square statistic. Okay. This will play crucial role for us to make a decision. We will fail to reject the null hypothesis, or we reject the hypothesis. Okay. We will look at the chi-statistics. And finally, we will calculate the number of degree. This is different from the section 10.6 because here we have the table. We have two-way table. So the degree here, df here, we will calculate it in another way. We erase this. Okay, the degree of freedom will be calculated by this formula. This is the row number, the number of rows minus 1 times to the column, the number of columns minus 1. This is the rows, this is the column. But this is what except the total row. And this one except the total column. What does it mean? So we will look at the table 1 here. Okay, we look at the table 1 here. So we just focus on the column and row like this. We don't care about the total. Okay, how to write here. We just focus on this one, this one, this one, this one. We don't care about the total. We don't care about the total, okay? We don't care about the total. So could you tell me how many rows and how many columns in this here. Okay, Arthur, please. 2 and 2, right? Okay, exactly. We don't care about the totals, right? So the DF here will be calculated by 2 minus 1 times 2 minus 1. So 1 times 1 equals 1. Okay? Let's see how to calculate DF. And when we know DF here, we know the level of significance. We know DF and we know the level of significance alpha. When we know this one and we know this one, we know the information, we can use the tree table. The table trees is critical value of chi-square here on your textbook. So you can find exactly the chi-square critical value or chi's alpha square. Okay, I also mentioned it in the previous handout, so you can find the previous handout. Maybe you have this chi-square distribution test for goodness of it, so you can find the table like this on the handout. But it's not in it's this handout. If you don't have that, you can use your textbook to find the critical value of chi-square here. Okay. In this course, we have two tables which are play crucial role. This is the normal distribution table. We have to have this table. Okay, normal distribution table. And the second one is critical value of chi-square. Okay, we need to have this. It's on your text. It is your textbook. No problem. Okay. And how to find this? Okay. I will show you how to do this, how to find the critical value again. For example, I have the alpha here, B005, and BF here is 1. So we can align the critical value here by using the table. So could you tell me, what is the critical value here? So you will find in the row BF here 1, and you find in the column DF and find the row here is 005, and after that you will make the intersection between them so you can find the critical value. So okay, Maria, please.
Is it 3.841?
Okay, 3.841 exactly. Maria, thank you. So this is okay. This number here is 3.841. Okay, so now when we find out the critical value, so you will compare them with the chi-test statistic we have found before. The number here is 1.5584. Okay, so we have two conclusions from this. If chi-statistic is less than chi-square critical value, then we fail to reject the null hypothesis. Otherwise, the chi-statistic is greater than the chi-square critical value, then we will reject the null hypothesis, right? Okay, in this case, we have the chi-square we calculated before is 1. I don't remember. It's a 1.5584. So it's less than this number. And after that, we will make a decision here. We fail to reject, right? Fail to reject the null hypothesis because the chi-statistic here is less than chi-square critical value, right? And after that, we will fail to reject this kind of hypothesis. Any questions so far? Okay, this is the way to do the test hypothesis. I will give you the example. Okay. When you do the hypothesis testing, we will have a lot of steps, so you have to remember these steps when you do the exam. In the exam, they will not give you. They will give you the step by step like this. Step 1 you do like this. Step 2 you do like this, and they will give you the hint in the final exam. So you have to remember the step by step when you look at the example here. So the example here is very similar to the online homework, so you can do it at home. So I will show you how to do this here. A new vaccination. Okay, I will write here. A new vaccination is being used in the experiment to investigate whether it's effective. Okay, and the sample size here is 236. Okay, we have 236 people in the study. And the question here is there sufficient evidence to determine if the vaccination and disease status are related? We have the vaccination status and we have the disease status. And the question here is, what are the association between them? What are the connection between them? Okay. And the step 1, state in the no and alternative hypothesis. Okay. We have two characteristics here: the vaccination status and the disease status, right? And the no hypothesis, that means that the two characteristics are independent. That means that the vaccinations and disease status are independent. That means that the vaccination and disease status are not related. And the alternative hypothesis is the vaccination and disease status are dependent. That means the vaccination and disease status have some relationship. Okay. That is the step 1. The step 2, find the expected value or expected count. Okay. How to do this? I will show you. Okay, when you do the expected count, you will calculate the table methods. We have the disease here. We have not disease. And we have the vaccination and not vaccinated, right? And not vaccinated. So this one is the expected count for disease and vaccinated. Right? I write down like this. And how to calculate this? And you can see on the table. You will count the total of disease, right? Because we have the disease here. So we calculate the disease here is 126, right? And after that, we will calculate the total of vaccinated. The total of vaccinated is 99 and over to the total of the people who are investigated. This is 236. And after that, we will get the result here like this. Okay. Okay, good deal. Okay, so how to calculate this one? This is not disease and vaccinated. How to do this? Could you tell me the total of the not disease, not vaccinated? How many people who are not vaccinated? The total. Okay. Aliyah, right? Sia.
So the total not vaccinated is 137.
Yeah, exactly. Technically 3 years. This one is 137, right? And the total of people who are vaccinated, This is not disease, right? It's not disease and vaccinated, right? Okay, not disease here. Let's see. Okay, this is vaccinated. You calculate the vaccinated, not vaccinated or vaccinated. Oh, sorry, it's not like this. I will calculate again. So it's the not disease. Sorry, not disease, and vaccinated, right? So we calculate the number of people who are not diseased, the total number of people who are not diseased. So could you tell me again, how many people who are not diseased? You get 99. Not disease,
110, not disease.
not disease, yeah.
110 110.
Okay, exactly. And who are vaccinated? Vaccinated is 99, right? That means 99. And it's one number. Thank you. That is the way to do this. So you can do this one similarly for disease and not vaccinated. So when you make a table, it's easy to make mistake when you do like this. Easy to make mistake. So be careful when you do this step. If you make some error in this step, so it will imply all the mistake in the hypothesis testing. Step 2 are very crucial. If you fail here, so it's make here fail, right? It's wrong here, so it will imply this wrong and it will imply this wrong. Okay, will imply all the result wrong. Be careful. And step 3, we will find the chi-square test statistic. Okay. You can do by using formula, or you can do using this table. Okay. The first column is observed frequency. So it will find down on the table here in the original table. We have 33 people who are diseased and vaccinated. So this is 43. And the expected value, the expected count here is calculated by this value. So we put in the column like this, right? Column like this. When you have this, so you will using the difference. You find the difference between them. Find the observed difference between the observed count and expected count. That is 0.14. 0.14. Okay. When you find this, you can find the observed minus expected count square by using this form. This one is exactly 0.14 times 0.14. So you will find this value here. Okay, might be, I think it's my mistake here. It's not the negative here, right? Because the negative, this square, so it will become the negative, this number times to the negative, this number, right? So the negative times negative is positive. So it's my mistake here, right? It's my mistake here. So I think it's make the wrong result, but luckily, so I get the statistic correctly. So please change this value to positive. It's not negative. It's positive. Okay, this is wrong result. This is not the negative here. It's not the negative here. Okay. So could you make the sum here? Could you tell me the sum here by using your calculator? When I just fix the result, fix my mistake. So the sum here is is all the chi-square statistic. Okay, Maria, please.
I got 0.00137.
137. Okay. Thank you so much. So that is the 0.00137. Okay, maybe you need to change this sum here. Okay. Chi-square statistic. Okay. Any questions so far to calculators? So it's easy to make mistakes. So I calculate it at home, and I make a mistake here. But the final result, I get the correct answer. But it's fine. Okay, that is the step 3. Step 4. Okay, so change this. Okay, I will revise this version of my lecture. I will revise this. Okay, find the degree of freedom. That means find DF here. The DF here is calculated by R is a row minus 1, and the column minus not plus, it's a minus. Okay, so I will. Would you tell me how many how many rows here and how many columns here, except the total rows and total columns. Okay, number 2, please. Yeah, 2 row and 2 columns, except the total column and rows. Okay, and this one is 2 minus 1, 2 minus 1, so this is 1. Okay, we find this here. And the level of significance here is 0, 0, 1. So after that, we will find the chi-square alpha, that or the chi-square critical value. So could you tell me how many? What is critical value here? If we have df here is 1 and alpha is 0, 0, 1. Okay, Maria, please.
6.635.
Yeah, exactly, Maria. Okay, this value here is like this. Okay, and final step here, you will compare this value and this value, right? So you see that the chi-square statistic is less than chi-square critical value, right? So we will enlighten us, we will conclude that, we will fail to reject, this type of null hypothesis. That means we don't have sufficient evidence to determine if vaccination and disease status are related. Okay. But you don't have enough evidence or don't have sufficient evidence to determine, right? But it depends on the level of significance. And you fail to reject the null hypothesis. Fail to reject doesn't mean that you accept the null hypothesis, right? Okay. Any questions so far about the chi-square distribution test for association? Okay, Maria, please.
So since we failed to reject it, does that mean that there is a related status between vaccination and disease, or there isn't?
When we fail to reject the null hypothesis, okay, what is the null hypothesis?
Vaccination and disease status are independent.
Independent, okay. And the question here is there sufficient evidence to determine if related? Okay. Okay, that means you are sufficient evidence, right? Okay, this depends on the question here. Okay, might be. It's just the sentence, so you understand the sentence, so you can write down the answer. Thank you for your question. Okay, the practice exercise you can solve here. The practice exercise is not the assignment. It's not the assignment. So you can do the step by step like this. So to practice. This you do by yourself. Okay, it is similar. It's not difficult to do. If you have any trouble, you can send me the email or you can meet me on my office. In my office, I will help you to understand the material. Okay. Any questions so far? Is it practice system? Okay.